Another strategy for finding the pattern for a quadratic sequence is to use a system of equations. So let's look at the system of equations from example 4, 6, 11, 20, 33, 50, and 71. And let's recall that this would be n equals 1, 2, 3, 4, 5, 6, and this would be a sub 1, a sub 2, a sub 3, a sub 4, etc. Now, I'm trying to find a quadratic sequence with this rule, a sub n equals a times n squared plus b times n plus c, where a, b, and c are constants. I don't know what those three numbers are. This would be the equivalent of trying to find a, b, c in the quadratic equation y equals ax squared plus bx plus c, only y is my a sub n, my term, and x is my term number n. So to find this rule, since I have three unknowns, I need to use 3 points and write 3 equations. So I'm going to pick the first 3 terms. Term number 1, which is 6, term number 2, which is 11, term number 3, which is 20, which corresponds to 3 points, 1, 6, 2, 11, 3, 20. And I'm going to set up a system of equations with those 3 points. Once again, I'm trying to do y equals ax squared plus bx plus c. I'm trying to find a, b, and c, but I know x and y. For 3 different points, I know x and y. So I'm going to substitute 1 for x, 6 for y, 2 for x, 11 for y, and 3 for x, and 20 for y into this equation, and then solve the system of equations to find a, b, and c. So notice I'm squaring the x value here and not here, and I end up with these 3 equations. 6 equals a plus b plus c, 11 is 4a plus 2b plus c, 20 is 9a plus 3b plus c. If I use the 4th point, this would be 16a plus 4b plus c, but I don't need that. I just thought I'd show you the pattern. Okay, so now how do I go about solving this? I went kind of quickly through the setup because there's very detailed notes printed online for that, but and they're color-coded and all kinds of things, but I want to actually talk through this solving of this. And notice I've numbered the equations 1, 2, and 3 to make them easier to refer to and show the process. Basically, when you solve a system of equations, we're going to do this by elimination. You could use substitution, but I think elimination is easier in this particular situation. We are going to pick a pair of equations and choose a variable to eliminate, and then pick a different pair and eliminate the same variable. The obvious variable to eliminate is c, because there's only one c in each one of those, and that makes it very simple to do. And I'm going to pick certain pairs for a certain reason. So the first thing I'm going to do is equation 2 minus equation 1. So 11 equals 4a plus 2b plus c, 6 equals a plus b plus c. Subtracting the second equation from the first, I end up with 5 equals 3a plus b. Now I'm going to take equation 3 and I'm going to subtract equation 2. And there's a particular reason I'm choosing these two. And this, for solving a system for a quadratic pattern, this method will always be the most efficient. 20 equals 9a plus 3b plus c. 11 equals 4a plus 2b plus c. Subtracting the second equation from the first, I get 9 equals 5a plus b. The reason I did 3 minus 2 and 2 minus 1 is in both cases I end up with just b for my second variable. And so now I can take these two equations. We'll call this equation, well, I don't need to number them, I guess. I'm going to take equation number, this equation, 9 equals 5a plus b, and I'm going to subtract this equation from it. Notice I don't even have to multiply by anything because I already have just the 1b. This turns out to be 4 equals 2a, so 2 equals a. So I know one of my variables. Once I know one, it's just a matter of substituting back in to find others. So for example, now that I know a, I can use this equation right here to find b. So I can say 9 is equal to 5 times 2 plus b. So 9 equals 10 plus b, so negative 1 equals b. Now that I know a and b, I can go back and pick up this very first equation, which would probably be the simplest to use, and say now 6 equals 2 plus negative 1 plus c. 6 equals 1 plus c, so 5 equals c. So now that I have all three of those numbers, recall what I'm trying to find here are the variables a, b, and c in this equation, or more specifically really in this equation. A sub n equals an squared plus bn plus c. I want to know those three coefficients. So since I've been using y and x, I'll write it that way first. So y is equal to 2x squared minus x plus 5, or a sub n equals 2n squared minus n plus 5. So that's a way to use systems of equations to find a quadratic sequence. If you can't see the pattern, obviously this is a quick way to do it.